Hello, everyone. Welcome to another webinar from Continuent. And this is part of our High Noon series. This is the first in the series. And this is all about looking at MySQL high availability solutions available now on the market. And today we're going to be looking at AWS Aurora. And let's see how it compares with Continuent Tungsten clusters. And we'll talk about building a Geo-Scale multi-region and highly available MySQL cloud backend. Again, my name is Matt Lang. I'm the Director of Customer Success here at Continuent for the Americas. And a little bit about me, so you know where I'm coming from. I was an early adopter of Linux. I even had it running on my desktop like over 20 years ago. And again, early adopter of MySQL and cloud technologies, really just because I found it all fascinating. But that led me to work for some startups, and I architected systems for several startups. And some of the requirements were supporting really high growth, and not just in sales, but employees and customers. And this touched the automotive industry, steel, medical field, as well as tech industries. So I was a MySQL DBA for a while. I was a Linux system admin for a while, and I did both. Also, site reliability engineer, cloud architect. That was pretty exciting. And I've got to use Continuent products firsthand for the first time. And I got to see some of the challenges of deploying into the cloud. I just happened to write also a replication tool for a company where we were using a proprietary database. And this was a long time ago, but we decided we needed a website for this. And that database just wasn't working for a website. So I introduced MySQL and I wrote a custom replication tool to replicate between this proprietary database and MySQL, and it's still in use. Weekend musician, that is me in the picture, not playing too many weekends these days, but hopefully soon. But that's kind of my passion. Anyway, let's talk a little bit more about Continuent and the subject at hand. So who are we, and why would we give this presentation? What do we know about this? Well, we've been in business since 2004, so 16 years already. And we've been able to see kind of the rise in MySQL usage, the explosive growth actually in MySQL usage, and how it's critical to the enterprise. Also, too, we've seen the rise of cloud computing, and we were using the cloud, really as soon as we could get our hands on it, because we knew that this was the direction that enterprises would be taking. So we've kind of seen all this, we've worked with it all, and we've been at the forefront of the market. Again, we have seen how important MySQL is and some of the limitations of MySQL when it comes to high availability and geo deployment. So we don't aim to be the biggest company. That's not what we do. That's not what we're about. We're about being the best and delivering our solutions that work, make sense, and we support and make businesses successful. So that is our goal. So if we're doing that, we're happy. And yes, we are doing that with a lot of satisfied customers, which we'll have a chance to see as well. So what is the High Noon webinar series? Well, if we're looking at high availability Geo-Scale MySQL solutions, this is what we want to look for. So in a particular site, we want rapid failover and high availability. So that kind of goes without saying. Systems going down is what keeps a lot of administrators and management up at night. So we want to solve that problem. So whatever solution that we choose should solve that problem. We also want our application to be deployed geographically. We really want it to be deployed close to our users. It really doesn't make sense to deploy it in a region or site and our users are far away, right? They're not going to get the best experience for that application. So we want these geographically distributed with low latency replication between them. Read traffic, we want good response time for that. We don't want users to have to wait when they load a page or anything like that. But if we have replicas, we want to use them and take advantage of them. Also, if we're deploying a Geo-Scale application, we would really like to deploy active clusters in regions close to our users. So perhaps we would want to deploy clusters on each continent, or maybe several clusters in different geographical regions within a continent or continents. And this would be to give the best performance for our customers by physically locating the clusters closer to them. Ideally, if we have an application, we don't want to have to change it. We want to do as least special coding as possible. So no application changes, that's a big plus. What else? Well, complex schema changes. It's hard to say your application is highly available if you do a schema change and your database is locked, say, for an hour. So at this point, your application is essentially down. Schema changes are a fact of life, and we have to be prepared for them. And ideally, we want the least amount of downtime when we're doing complex schema changes. And then one other thing, it would be great if we could avoid vendor lock-in or provider lock-in. When we're locked into a particular vendor, now we feel like, maybe our data is held hostage or we're being held hostage. And we really don't have a lot of leverage or negotiating room, whether it's price or features or performance. So, and just FYI, when we say MySQL, we really mean MySQL, MariaDB, Percona Server, and all its variants. So let's get into the High Noon series. This is a new series where we are comparing other MySQL clustering products to Tungsten clustering. And we're going to look at a bunch of products. And what we do is we do a deep dive with each product and we rank them and we figure out what features they have, what they don't, and how well each feature works. And we're able to roll them up into kind of a scoring system, right? From 1 to 5 in each of these areas. And when you're looking at a package for an enterprise cluster, these are pretty much, the main features that you're going to be looking for. Continuous operations, right? You want your cluster to be running, your application to be online 24/7. You'll probably want to be able to scale it as well. Hopefully, you're going to have an increase in traffic, increase in business, or more drive to your website. So you want your backend cluster to be able to handle that. Um, are you going to be able to do a geographic deployment, right? Or a geo deployment? Or is it just a single region only? So we'll look at that as well. And then how is the overall performance? Are we going to take a performance hit by putting in a cluster, or are we actually going to be able to improve the performance of our application with our cluster? And then what is our application see when it connects to our cluster? Does it have to be modified? Is there some sort of change that needs to happen? Or can we just install a cluster and our applications are going to work fine? And that's what we mean by transparency. And then, of course, security is always a big issue. And so we'll definitely look at that. And that's something that's coming up more and more. So we definitely want to make sure that all of our products do support good security. And then, of course, once we get this deployed, it might be a complex system. We need a good tool to manage the entire deployment in the entire topology. And with that, too, we need to be able to monitor what's happening within our cluster so we can react if things don't look right. And then lastly, once we have our complete topology, our complete deployment all set up and running, how easy is it to replicate our data out or get our data out and load it into some analytics tool where we can have a look later and run complex analysis on our data? So one other thing too, really important is support. Um, there are always going to be questions, always going to be issues, or maybe something that you just don't understand. And so, where will you get your support? Some options are online forums, right? Maybe not the best place or the most up to date information. The information in a forum isn't necessarily verified. um, Perhaps it's an email system, right? Where you email support and then the next day you'll get an answer and you'll reply to that and wait another day for an answer. Or maybe you actually get a live person, an engineer with experience. That's obviously worth a whole lot more because you can get your questions answered much more quickly and get it directly from the source. So we'll see how all these solutions compare with support. And then, of course, we talk about intangibles, right? Um, we're clustering MySQL. So, what versions of MySQL do we support, right? Or which ones does a particular solution not support? So, that's also important if you need certain features in a certain version of MySQL. And when we say MySQL, that could be MySQL Enterprise, MariaDB, Percona, any one of those variants. Platform's important. Are you going to be deploying in the cloud, hybrid cloud, maybe on site? So whatever solution we pick has to support our target deployment. And then product maturity, I think that goes without saying. The more mature a product, the more time it has to have bugs worked out and features put in as well. And then with all this said and done, what's the total cost of ownership, right? And how much does the physical software or all the pieces cost? But also, what about support? And what about man hours and learning the product and, really time spent on implementation, right? And that's what we call total cost of ownership. And then lastly, what we'll be looking at are the various use cases. So we see right here, we can have a quick look. We have pretty good support for HA. Each product handles it a little differently, some better than others. And we'll look at how they handle HA. DR, or disaster recovery, not everyone supports that, but it might be something that you need. You may want to avoid a catastrophic situation in a particular region, and you may need to fail over to another region or another site. Zero downtime maintenance is also important. And I think every DBA has gone through this where there has to be some major maintenance. How is that going to impact the application? Or does it even impact the application at all? And again, that flows with continuous operations, right? We need our application to be up, especially for large enterprise applications. We can't afford downtime. Um, and that includes maintenance. Okay. And then what about some other features like having multiple primaries? Is that something that we want to have? How about a geo-deployed active passive cluster? So we can fail over and we can also fail back and we can leverage the DR site maybe for reads. Getting even more complex active clusters, right? Deploy a Geo-Scale topology where you have multiple active clusters and all replicating to each other and all in sync. And this goes, again, leads into Geo-Scale clusters, right? Can we deploy globally and have our applications close to our end users? So that's kind of the overview. Let's get into it now. So let's go over Aurora and let's look at some of the key features that Aurora offers. It's become pretty popular, and there's a great marketing strategy behind it. But what is it exactly? Well, uh, two versions, MySQL or MySQL 5.6 or MySQL 5.7 compatible. So it's not exactly MySQL. They took MySQL and modified it, which we'll see uh, just in a minute, but it's a MySQL compatible solution, right? So it's not based on MySQL 8 or MariaDB 10X. You don't get those features, but we'll talk about that in a second. But it does offer read replicas. So you create a primary, and then you create a number of read replicas in the cluster. So that's great. What's interesting about Aurora is it uses a distributed file system. So when you create an Aurora cluster, it's not a directly attached, volume where your database is stored on. It's a file system that's actually distributed across the region, and it's distributed like 6 ways. So it's pretty high performance, and it's very durable. So this is one of the key things that makes Aurora different, and one of the features actually. And because of this distributed file system, queries can be pushed down into the storage layer. And they're able to squeeze some extra performance out of that. And it's actually a pretty slick system. So your read replicas actually will share that distributed file system as well. So it's one big distributed file system that everyone in the cluster reads and writes to, right? Well, there's one writer and everyone else reads from that same file system. You can create cross-region replicas in Aurora, obviously as long as they're within AWS, and it'll use asynchronous replication within the Aurora ecosystem. Now, if you want to promote that read replica to make it active, it becomes its own standalone DB cluster. So obviously it will no longer replicate from the old primary site, and anything else replicating from it is disconnected. So it's its own standalone DB cluster at that point. And if you want to now create another cross-region replica, you can go ahead and do that. And as we mentioned before, Aurora can be fast in specific scenarios. There are scenarios where maybe it's not so fast, but definitely in some scenarios it is fast. And that's thanks to that distributed file system and doing parallel queries and pushing a lot of the stuff to the storage layer. So there is now just within the past couple of months, they've released a proxy for RDS and works for Aurora, obviously. So that's available. It's pretty basic, and there is an additional charge for that, again, by the hour and number of CPU uses that you've deployed. And then there's also a serverless version of Aurora. So what's serverless? Well, typically when you run Aurora, you're paying by the hour amount of RAM, CPU, and that can get pretty expensive. So what serverless tries to do is it scales up to a defined limit that you put on, and it scales down. So if, for instance, you have a workload where maybe a couple hours a day, you really need a lot of CPU, it'll make it available for you, and you'll pay for it. But when that workload starts to go down, and maybe it goes down to almost zero, um, then your CPU usage goes down, and thus your costs go down. So it's one way to, save a little bit of money, basically, because it is a fairly expensive service. So you want to utilize what you have and not over provision. So that's what serverless can give you. So if we're looking at cross-region now, what are the requirements? So again, cross-region means that we can deploy a read replica in another region and use asynchronous replication to get replication events to that read replica. So obviously, we need a source Aurora cluster, right? We need an active cluster already. Then we need to enable binary logging on the source Aurora cluster. So out of the box, or when you first create an Aurora cluster, binary logging is not enabled, right? It's not needed for an Aurora cluster. So you have to go and actually enable that. So there could be a small performance penalty, and it's not like doing it with MySQL where you can just, one command or one option enable binary logging. You have to go through some of the parameter groups, and there are quite a few settings that you have to change. So it is kind of um, it's not a huge deal, but it does take a little bit of research to get it right and to get the retention time what you wanted as well. Uh, so then we need a VPC in the target cluster, right? And then we need a subnet within that VPC. And this has to be done exactly right. If you, in general with Amazon, if you don't get your VPCs and subnets created correctly, it's a lot of work later to go and uh, basically redo it and reprovision your machines into the correct subnet or VPC in VPC. And if you want this replica to be publicly accessible, then we need to make sure that the subnet is publicly accessible. So that's kind of a big deal too. If we forget that, then we need to recreate the subnet, make it publicly accessible, and then redeploy our database into that new subnet. So when we're doing this, we want to get it right the first time. Otherwise, it's a lot of extra work on our part. And um, and yeah, let's talk about the RDS proxy because it was just introduced in June, so June 2020. So it's brand new. It was in beta for a while, but now it's generally available. So now that it's been out for a few months, definitely we want to take a look at it because if we're using RDS, it would be helpful to have some sort of proxy. So, what are the main features? Well, it can reduce failover times up to 66%. So, you know, failover could be two-thirds faster. So that's pretty good, especially since a typical failover in Aurora can take 30 seconds or more. Uh, it also preserves application connections. So that's also important, right? During a failover, we really don't want our applications to become disconnected from the database. That'll just give our users an error message and it can wreak havoc on applications. So that's a really important feature. Um, it also integrates with the AWS IAM manager. That's a good feature as well. That can make it easier for us so we don't have to deploy passwords on our application server, the database credentials. So that's good, great for security. It supports connection pooling and reusing connections. Why is that important? Well, uh, MySQL is defined with a certain number of connections, right? Maximum connections. And you can change that, but if you start raising it, it uses more resources and it really uses more OS resources as well. And it could be a sign of an application that's having a problem with its connections. Or it could just be an application that from 1 hour a day needs to burst a ton of connections to the backend database. But besides from that, it really doesn't need that many connections. So connection pooling can help out. It'll help reuse those connections and it'll take a lot of the incoming application server connections and minimize the connections outbound to the database. So that is a nice feature. So what it doesn't do, though, unfortunately, there's no read-write splitting. So one of the kind of cool things about Aurora is there's really no slave lag. Um, no, on your replicas, they're really caught up to the master almost all the time. But if we can't do automatic read-write splitting, it makes it hard to take advantage of um, those replicas. So, we would have to recode the application, and this is something that we would hope a proxy would do. Uh, so with that in mind, Aurora Global Database, where we have replicas deployed in multiple regions, we're not going to be able to direct reads uh, to those other regions or back to um, the primary region for a write. It doesn't support Aurora serverless at all. So if you're looking to kind of cut costs, you're not going to be able to use the RDS proxy. And then again, it must reside in the same VPC as an Aurora cluster. I actually don't know why there's this limitation, but it's just something that you need to plan out. Uh, if you were to deploy this, say, if you had a separate VPC for your application cluster, you can't deploy the RDS proxy there. It has to be in the same VPC as the Aurora cluster. So when we're talking in the context of Geo-Scale and high availability or disaster recovery, what are some of the limitations or things that we need to think about when using AWS Aurora? Well, we have a single primary. So we have a primary in a single region. And if we have customers or users in other regions, they are going to have to write to that primary. We can't deploy multiple primaries in a single cluster uh, that are cross-site. Without RDS Proxy, failover is going to disconnect your application. So if the primary fails and a read replica is promoted to primary, your application will be disconnected. That could give some error messages to your customers, but also it can make your application crash, which is not a good thing at all. Failover times can be greater than 30 seconds. That's a lot by today's standards. And that could really be catastrophic for certain customers or batch processing, for instance. It only supports NODB, although that is really the most popular database engine for MySQL. Applications need to be read-write aware. And it doesn't matter if you use RDS proxy or not. If you want to take advantage of the read replicas and the zero latency that they provide, you have to somehow direct your applications, uh, direct the reads to those read replicas. You're not going to be able to do that out of the box by using Aurora, even with RDS proxy. Um, so all of your data is going to be in AWS. So you may or may not be comfortable with that, but if you want to get your data out, it's going to be sort of a challenge, right? There are scheduled database maintenances that happen in RDS. Those are automated and they might be patch upgrades, but it's something you will have to plan for. You may be able to specify a window of when they could possibly happen, but it will happen. So in that case, your application will be offline. So you're not going to be able to achieve, say, 4 or 5 nines with these patches. And then it is a proprietary database system. It's not open source. And that may not matter to you, but it may if you're interested in code review or bugs or patches. You really, at this point, you're really waiting for AWS and their schedule. So how can we do this better? How can we do Geo-Scale, high availability, or disaster recovery better? Well, we do this all the time at Continuent, and our core product for this is Tungsten Clustering. What it does, it provides continuous MySQL operations, um, zero downtime maintenance, and it's highly available. And we can distribute this uh, in different regions, different cloud providers, or on-prem, or mix and match. We really don't care. We're agnostic, but we can deploy these clusters and connect them all together in multiple regions or sites. Again, multi-cloud, use several clouds or use hybrid cloud. Use your on-prem and deploy another site in your favorite cloud provider. We do provide a proxy. We call it the Tungsten connector, and it does full read-write splitting. You don't have to change your application to use it either. If your application already knows how to do read-write splitting, great, we can utilize it. But if not, that's fine too. We can intelligently do read-write splitting for you, and we can leverage those replicas that you've provisioned. Uh, we fully support MySQL, so that includes MariaDB, Percona, all versions, and there are no changes needed to your apps at all. Any SQL that you're using now, any SQL statements or queries, will fully work with tungsten clustering. So let's have a look at some of the topologies that we offer. Um, First is tungsten active passive clustering, right? So we can deploy multiple clusters and connect them all together, and we can deploy these in multiple clouds, multiple data centers. They can run on-prem, they can run on bare metal if you want, or any combination of cloud and on-prem or VM that you like. Mix and match cloud providers, for instance. But how this works is we have a single active cluster with an active primary, and all writes are going to go to that primary from wherever, right? But we have other sites deployed that are passive sites. So we can read from any node in that site if we want to. And then we direct all of our write traffic back to the primary. So we have a single primary, and that makes for a really simple deployment. A single primary is really what everyone is used to, like they're writing to a single MySQL database. But what we can do is we can move this primary and we can promote one of the passive clusters to become active. And the site that was primary is now passive, right? So, for instance, this is perfect for DR. If one site goes down, we just flip the primary site to a working primary site and run from there. And we can have these deployed across continents. We can have, say, 4 or 5 of these sites if we wanted to. But the advantage here is it's a single primary that can move, but we can still read from any of the replicas in any of the clusters. So we can read from the node that's closest to the end user. Now, we also offer active-active clustering, and we're really the only ones that do this. And we've got this down pretty good because we've been doing it for a long time. So again, we can deploy clusters, VM, bare metal, various cloud providers, whatever you want. But all sites are active. So that's the key. So we can deploy these clusters and have them close to our users. Again, maybe we can span the globe or maybe certain regions across the country, right? And deploy these clusters closest to our users. They're all taking traffic. They're all reading. They're all writing. And if a site goes down, we just direct those users connected to it to another site. And all sites are replicated between each other. So they're all in sync. They all have the same data at the same time. So this is really powerful. This is a way that we can really scale our application and give our users the best performance by physically locating the clusters close to them. And real quick, in any topology, just to talk about zero downtime maintenance, um, if we want to do zero downtime maintenance, it's really easy. So let's say we want to upgrade MySQL, or maybe we want to retire a machine and replace it with a new one that's more powerful, whether that's in the cloud or on-prem or VM. But the idea is all the same. We do a process, we shun a replica, do whatever upgrade or maintenance we want to do, uh, put it back into the cluster, right? And we keep repeating that for all the replicas. Now all of our replicas are upgraded. And then finally, we promote one of the upgraded replicas to primary, right? And the old primary is now a replica. We take it out of the cluster, do our maintenance, our upgrades, whatever we need to do, and add it back in, and we are all done. And our application is not offline. It doesn't even know what was happening in the background. So it's really powerful stuff. This is how we um, get such high HA numbers. Let's come back to our scorecard and see how AWS Aurora compares to tungsten clustering. And let's look at some of the main features and benefits. First is zero downtime maintenance, and tungsten clustering is the clear winner here. And the reason why is because you can do database patches, database changes, operating system upgrades, even schema changes without incurring any downtime for your application. Aurora will take your database down when they need to do patching, and other operations too would require a maintenance window. So there is some period where your applications would be offline with Aurora. When it comes to high availability, both systems support high availability. With tungsten clustering, it's an automatic failover, and that usually happens within a few seconds. Aurora, that Failover can take up to 30 seconds. They also have a DNS change along with that, so it's not really transparent to the applications, but it does fail over. How about active passive clusterings? For instance, if you have a DR site, with tungsten clustering, a single command will fail over to your DR site. With Aurora using global database, that could take a few minutes. And that will keep your application offline for that period of time. How about DR with active cluster? Pretty easy with tungsten clustering. We simply report the applications to the DR site or the other site. It's active, so there's nothing else to do. Aurora doesn't handle active cross region, so it obviously does not support that at all. How about fail back from DR? So if you fail over, that's great, but how do you fail back to your primary location? Again, with tungsten clustering, it's really just a single command that's called switch and happens in a few seconds and everything syncs back up. With Aurora, if you fail over to another region, uh, the only way to fail back is to reprovision the failed region. There's no really fail back mechanism available in Amazon Aurora. Backup and recovery with tungsten clustering, you just use the tools that you're used to, whatever tool you want, it's there. Um, Aurora handles it quite well too. They have their own managed and proprietary system for taking backups and doing recovery. So let's move on to scalability. So how about read replicas? In Tungsten, you can provision read replicas, not a problem. Amazon Aurora handles that quite well as well. Um, Now, physical location. Let's suppose you wanted to have kind of a hybrid deployment or a multi-cloud where you didn't want to be locked into one particular provider. Tungsten clustering, deploy anywhere. So whether you want to do on-prem, virtualization, or any cloud, if you're geo-deployed, do hybrid cloud, multi-cloud, fully supported. Aurora supports the cloud, but basically just Amazon, obviously. So it's quite limited in that respect, and you'll be locked into Amazon. Uh, Scalability as far as instance size. With tungsten clustering, uh, choose whatever instance size you want as long as it meets the minimal requirements. With Aurora, a lot of options for instance sizing. A database node auto scaling is an interesting one. So with tungsten clustering, it would require manual steps to scale your database servers, either up or down. You would combine that with the zero downtime maintenance features in tungsten clustering to keep your applications online. So you wouldn't incur any downtime, and you would just use that process to rescale your database nodes. Aurora out of the box does not support autoscale. However, there's another version of Aurora called serverless, which is a reduced functionality version of Aurora. However, you do get autoscale. So if you really want autoscale, you would trade that for other functionality that you would normally get with Aurora. And overall DB cluster scaling for the enterprise, tungsten clustering is great for software as a service applications and really lends itself well to pod architecture and automations. Aurora is great for DevOps, and a lot of developers like to use it too, just to spin up quickly some test clusters. On the geographic front, um, we see that this is where, again, tungsten clustering really shines. It's made to be geographically distributed, right? Hard read replicas can span uh, regions, sites, availability zones, and even clouds. Amazon Aurora, obviously, the read replicas are going to be within AWS only. Active geo-deployed clusters, tungsten clustering again supports this, and it's been in the product for years. And we support active clusters, whether it's in the cloud, on-prem, or hybrid cloud or multi-cloud. Again, Amazon Aurora, it's deployed only in Aurora, and they don't support active-active clusters. Same thing with active passive. Tungsten clustering supports across cloud. Amazon Aurora does have support for active passive in AWS. Let's compare some of the performance features between these two clustering solutions. Uh, One is called Smart Scale, and that's automatic read-write splitting. So, do we have a system where your applications can automatically have their read requests routed to a replica? And the application really doesn't need to do anything. With tungsten clustering, that's possible because it includes the tungsten proxy, and that's the intelligent proxy that allows this to happen, where it inspects the SQL and forwards reads to a replica. And that obviously keeps the load off your primary. With Aurora, even though they have read replicas, there's no included proxy that does that. So you would have to have a third party proxy to do that. So that adds a little bit of complexity to your clustering solution now. Load balancing, again, the tungsten proxy includes a bunch of load balancers, so you can load balance your reads across your replicas. Um, Again, Aurora, either you need another proxy or you need some sort of application awareness to do this for you. It's not automatic, and it's not something you can just push a button and install. Up-to-date read replicas, tungsten clustering uses asynchronous. That's going to be the best performing replication mechanism. Amazon Aurora uses a proprietary distributed file system that's pretty slick, and the read replicas are up to date. Um, Overall, your database performance. With tungsten clustering, you're using regular off-the-shelf MySQL, Percona Server, or MariaDB, really whichever flavor you'd like. You can tune it as you like, and you're going to be using asynchronous replication, so that really does not add much overhead at all. Um, and with Aurora, you can tweak most of the regular MySQL parameters that they let you tweak. Okay. Next is what we call transparency. How do these solutions look to our application? Um, do we require any application changes or not? Tungsten clustering requires no application changes, and that's really complete. Even if you use some of the more advanced features like the load balancers that we talked about, your application does not need to change. Um, Aurora is pretty good with this too. The only thing is there are some advanced features like in MySQL 8 or MariaDB that may not work with Amazon Aurora. So if you require any of those features, you're kind of out of luck with Aurora. Um, and what versions are supported? Tungsten clustering, MySQL community, the enterprise version, MariaDB, Percona server, all versions. You can even mix versions if you'd like. Uh, Amazon Aurora is based on MySQL 5.6. Most 5.7 features are supported, but not really MySQL 8.0 or MariaDB 10 support. And Tungsten clustering is compatible with all database engines. So if you're still using MyISAM or you have some other ones out there that you're using, it's compatible. Amazon Aurora supports NODB only. And we'll see a lot of other um, competitors that are doing this too. They're dropping support for some of the other MySQL database engines. Uh, a really important topic lately is security. So, how do these solutions handle security? So, the first really is encryption at rest. So, what's encrypted on your disk? Tungsten clustering can just leverage whatever technologies you want to use. So, if your cloud provider encrypts the disk, great. If you want to use your own encryption, great. Uh, Amazon Aurora handles this well. It's got built in encryption. Uh, how about encryption over the network in flight and SSL? Tungsten clustering, fully supported. Amazon Aurora also fully supported. And how about compliance standards? So if we want to use this with a PCI or HIPAA or some other compliance, and we're running an audit, do do these systems work for that? And yes, for security standards, privacy, both systems handle this just fine. Looking at the management monitoring layer, how easy are these to deploy? Tungsten clustering, easy to deploy. Amazon Aurora, also easy to deploy. Cluster management, Tungsten clustering has a web-based GUI, and that web-based GUI will see your entire cluster over all regions or all clouds. It's really agnostic as far as what it can see. It just sees everything, the complete deployment. The Amazon Aurora is within the UI, and it can view a single region at a time. So that's a little complicated if you have a cross-region deployment because you're looking at one region at a time. How about monitoring? Um, Again, tungsten clustering, web-based monitoring, full GUI, supporting Prometheus. Amazon Aurora supports monitoring. It has some pretty good monitoring. If you really wanted to go to in-depth, enhanced monitoring, there's going to be an extra charge for that. Alerting and notifications, again, tungsten clustering uh, integrates with almost any system out there. And you can really do simple stuff on the command line if you really wanted to create all kinds of alerts and notifications. Um, Amazon Aurora is going to be done through the AWS API, and you have to configure it. So there's some limitations there, although the AWS API is fairly advanced. Um, OSDB patching, uh, you can do it with scripts and with tungsten clustering, and most importantly, zero downtime. Amazon Aurora will patch your database automatically. However, it's going to cause uh, downtime. And another thing that's really popular is replication into analytics. So we have our MySQL cluster or clusters, and we want to run analytics. How do we do that? How do we move the data from our MySQL clusters to our analytics system? So Tungsten clustering actually supports this real time with supporting a bunch of targets. So AWS Redshift, Hadoop Vertica, MongoDB, uh, Elasticsearch, and there are a ton of others. That's real-time replication, and so no need for ETL. Uh, Aurora does not have this functionality built in. There is some support for going to Redshift, which of course is an Amazon service, um, and the tools for doing anything else are going to be external. How about filtering? So what is filtering? Filtering is when we're replicating, but during the replication stream, we want to change something. Maybe we want to rename the database schema. Uh, Maybe there are certain tables that we don't want to replicate or certain columns, or we want to run some transformations. Uh, Tungsten clustering supports complex filtering at schema levels, database levels. So when you're replicating in the analytics, that's really helpful because you don't have to replicate, say, like your blobs and stuff that you really don't want to run analytics and have it filling up your analytics database. Amazon Aurora supports basic MySQL replication, which is fairly limited. Uh, Cluster aware. So if you're doing any kind of replication, is the replication aware of the cluster? So what that means is if you're replicating into, say, a data lake, let's say to Hadoop, and your primary goes down, a replica is promoted. Does the replication tool know about that? With tungsten clustering, yes, the replication streams are all cluster aware and aware of what's going on within the cluster. With Aurora, your tools need to be designed to do that. There's nothing provided to allow that. One of the most important aspects of using any tools is support. Uh, Questions happen, things come up, or you just need some help. So where would you get that? Tungsten clustering includes 24/7 support, 100% customer satisfaction. With Amazon Aurora, you get basic support. So That's usually 12 hours or more. You can get business critical enterprise support, but that's really expensive. How about response time? We're pretty proud that Continuent, we average less than 3 minutes when there's an urgent request. We take those extremely seriously. With Amazon Aurora, you need to be paying the extremely high enterprise support fee for any kind of quick turnaround like that. Support team experience. All the members of Continuent have at least 20 years experience with DBA roles, site reliability, and admin. With Aurora, it's really unknown who is going to be your first level of support, if it needs to be escalated. So you really don't have a guarantee there. With tungsten clustering, all levels you get the highest level of support with your ticket. You don't have to go through multiple levels. And as we mentioned, as far as tungsten clustering, MySQL Community, Enterprise, MariaDB, Bracona Server, all fully supported. With Amazon Aurora, you get MySQL 5.6 compatibility and most of 5.7 features, and that's it. Okay. And real quick, where do we deploy this? Well, with Tungsten clustering, again, on-premise, cloud, multi-cloud, or hybrid cloud. With Amazon Aurora, obviously, it's going to be deployed in Amazon only. So you're locked into Amazon if you're using this service. So we think of tungsten clustering as a complete solution, right? Because it has all the components needed for enterprise clustering without changes to your applications. It's fully tested and it supports all topologies for high availability in Geo-Scale. Uh, Amazon Aurora is great for HA, local HA, with some support for DR, but not really much support for Geo-Scale, especially when we think about active deployments. Um, if you really want to get the most out of Aurora, you could use RDS Proxy and pay extra for it, but it really is not going to leverage all the features in Aurora that you would want. So you would probably have to use a third-party proxy or develop something within your application to take advantage of the RAID replicas. Um, Fully tested, um, it's unknown what the testing methodology is, but it is definitely widely deployed. And total cost of ownership. So how much does it cost when, the instances, the actual acquisition of the software or whatever it is, but also the support and the resources needed to manage and deploy it. So with tungsten clustering, uh, we don't care about the instance size. You could deploy the biggest instance, that's not going to affect your pricing. And it's not a linear pricing model. As you add nodes, the price per node comes down. So we work with our customers to develop a long-term relationship so that there are no surprises and it's fully understood, and customers are free to deploy as much as they want. And we come back later and true up. With Aurora, it's a linear pricing, right? You know the cost per hour and multiply that by the number of nodes. Um, if you use a larger instance, obviously it's a little bit more expensive for that larger instance. Tungsten clustering includes support, the 24/7 support that we talked about. Aurora includes a very basic support, but you can get an enterprise level support. But again, the cost is extremely high. Um, how about the number of database resources needed? Uh, so there is no really solution out there that's going to eliminate the DBA. Amazon Aurora makes you think that, well, okay, it's a managed service, but you really do need DBAs to make this thing work well. Um, with tungsten clustering, uh, again, you will have DBAs, but a few DBA resources can manage a large number of clusters. And part of that is thanks to all the automation that can be done with tungsten clustering. So the use cases that are supported, right? We see that when it comes to high availability, DR, zero downtime maintenance, continuous operations, and then all the geo-scale, multi-primary, active-active, active-passive, and geo-scale, we see that tungsten is really made from the ground up to support all this. And with Aurora, the strength there is local HA. That's the big strength with Aurora. So I've spoken about continuant solutions. Let's talk about our products just at a glance. We really have three main products, tungsten clustering, replicator, and dashboard. Uh, Tungsten clustering, this is what we've talked about, right? Continuous MySQL operations, zero downtime maintenance. We deploy Geo-Scale. We deploy using multi-cloud or hybrid cloud technologies. We include an intelligent proxy that does automatic read-write splitting. And we support any version of MySQL. And again, that's MariaDB or Percona without any changes to your applications. So I've talked about our customer service and our support. Again, we have a 1 hour SLA for urgent cases. Those cases we track very closely. We end up really less than 3 minutes for our initial response. So that's why our customers are able to measure their uptime really in years. And um, we all have experience with cloud technologies, Linux, systems administrations, and site reliability engineering. Uh, so, how does this translate into cost savings? Well, first of all, use whatever MySQL that you're used to using, right? If you want to use the free open source MySQL, that's fine. We fully support that. Um, you can choose which cloud environment you want to use um, because we run on any cloud environment. So if you get a deal with a particular cloud provider, feel free to use it. We run in any cloud provider. So that's one way as well that this optimizes your costs. And of course, downtime uh, can be looked at as a major expense. So we eliminate the risk for downtime and those costs, and that includes your maintenance operations. And DBAs can spend more time doing, what DBAs should be doing, improving the performance, rewriting queries, um, doing architecture, instead of, really menial activities like admin and recovery. So again, continuous MySQL operations. So we do HA. We've been doing this for 15 years, and our failover is immediate. So there's not an interruption to your business. And your MySQL recovery time now, if there is, any sort of catastrophic event, could be reduced to seconds, right? And our dashboard provides a graphical view and maintenance tool for all clusters, whether they're geo-distributed or not. And we'll look at that in a second too. With zero downtime MySQL, we can do site level and cross-site failover really quickly, right? This keeps your applications online and it keeps them from being disconnected as well. And that's because of the uh, tungsten connector. This is great also for upgrading hardware, software, doing any OS patches, again, without taking your applications offline. And we're fully MySQL compatible, well, because we're using real MySQL underneath, and it's really whatever MySQL flavor you would like to use. Of course, one of our big strengths is the Geo-Scale MySQL. We can load balance MySQL read operations across multiple replicas. We can use replicas locally. We can use replicas deployed on a global level so that applications can read from a local replica. Again, geo-distributed MySQL clusters bring your data closer to your application users for better performance and faster response times. And you can add MySQL clusters for scaling. You can add MySQL nodes too as well if you want to do scaling that way to add more replicas for better response times for your reads. Uh, Because we are agnostic when it comes to cloud or whatever sort of hardware is underneath, you could deploy in the cloud, you can deploy in VMs, you can deploy on-prem. You can mix and match clusters as well. You can have a geo-deployed cluster with one site, say in Amazon, one site in Google Cloud, and another site on-prem. It really doesn't matter. But you can also fail over and fail back from these different private and public clouds or whatever platform you're using. Um, and obviously, if a node or a provider or any sort of regional failure happens, it's easy to fail over to another site or another provider. Tungsten clustering includes an intelligent MySQL proxy that we call the Tungsten connector. And it really has a lot of features, but the important feature that we want to point out, at least in this context, is that it's traffic routing. It will route to a local primary. So if we have multiple primaries deployed in different sites, it'll route to the local primary, and it can route read applications or read queries to local read replicas. And during any sort of failover event or switch event, applications are not disconnected. So your users still have a good experience even when a failover happens. And we can do kind of really cool replication with filtering, transforms in flight. Uh, if you want to use, say, replication to a non-MySQL target, we can do that. So you don't need ETL anymore. You can do real-time replication right into your analytics, and your analytics is up to date at all times. Um, and with the Tungsten replicator, there's no charge for the amount of data or CPUs. It's just a pipeline. And we just replicate all the data from your cluster or your MySQL source to whatever target you choose. Again, this is a bolt-on application, so it's fully MySQL supported. We can use any sort of MySQL that you want, any flavor, no changes to your application. Just deploy and configure your MySQL cluster, and it's minutes. You use the same MySQL that you're familiar with. So whatever version that is that you want to use, that's what you can use. And there's no difference in your MySQL configuration. We do support SSL, which is extremely important. SSL for all in-flight traffic. So that could be your queries, replication traffic, or even the internal cluster communications, all SSL with encryption. And of course, native MySQL support. Another product too, we haven't really talked about it much, so I'll just go over it really quickly, is the Tungsten replicator, right? And that allows us to replicate from MySQL to a bunch of targets, right? Again, we can actually replicate to Aurora or RDS, but more importantly, Redshift and analytic targets, right? Vertica, Hadoop, Kafka, there's a bunch, Cassandra, Elasticsearch, and this is really useful for multiple clusters. So for instance, if you have multiple MySQL clusters deployed and you need all the data and all these clusters to be merged into a single target, like say a Hadoop target or Vertica, the Tungsten replicator can handle that for you. And it'll do all kinds of complex filtering. Typically when you're running analytics, you don't really need every single piece of data, right? Especially blob data. We can filter that out for you. So just the data that you need to get into your analytics gets replicated to your analytics. It's really flexible. There's a whole lot of filters that you can do and transformations of your data as well. And if you want to give it a shot, it's available actually as an AMI in the Amazon Marketplace. You could fire it up and it'll prompt you with the sources targets and it'll happily go along. So feel free to try it. Uh, One other target, just our product, just really quickly, Tungsten Dashboard. This is our GUI management tool for Tungsten clustering. So with this, you see your entire cluster. Even if it's geo deployed, you see all sites, on a single page. You don't have to jump around between different sites. And you can do all your maintenance here. You can see our global transaction ID, the replication progress. You can switch. So switch a primary and a replica to promote a replica to primary. You can do failovers, and it also does monitoring as well. So this is a really powerful tool. And if you're using tungsten clustering, it'll manage all of your clusters again on one single pane. And the best thing is it's included with tungsten clustering. So you don't even have to pay extra for it. All the monitoring and everything is included. So if I can just talk about Continuent as a company real quickly. Again, we've been around for a while. It's been over 15 years already. And we only have experts here. Everyone is an expert on replication, databases, site reliability. Our support team, again, same sort of experience. Everyone on the support team has at least 20 years of database and high reliability experience. And that allows us to effectively respond to our customers' needs, questions, or even just to chat about architecture or technology. And of course, we're extremely proud that an urgent case we typically respond in less than 3 minutes. That is our average response time, less than 3 minutes. So that's another reason why our customers stick with us because they know when, if they have an issue or a question, even, they can get a hold of us. So here are some of our customers. And these customers have been with us for a long time, and it spans a lot of different industries: the medical industry, uh, finance, technology, telecommunications, and gaming, as well as some other industries. So we're pretty well represented in the enterprise space and software as a service space. And why do they choose Continuent, or why did they? Well, we've on all of our surveys, we have 100% customer satisfaction rate. And that is our goal. We're constantly thinking about our customers and we want that 100% customer satisfaction. And that's what we work for. Uh, Renewal rate, again, 97.5 and multi-year renewals. And of course, companies get bought out and they may have to adopt different technologies. They may even go off of MySQL. And so that would account for like the 2.5% that don't renew, but that's a pretty small percentage, and it's usually due to a buyout. Again, average response time less than 3 minutes for urgent case, and that helps fuel the 100% customer satisfaction rate. And our average customer has been with us for 7 years, so we do value a long-term partnership. That's another thing that we work for is that long-term partnership. We're not looking to, for a 6-month commitment and then say our goodbyes. And just some interesting facts. So we're the MySQL availability company established in 2004. And I've mentioned some of the industries that are represented with our software. Um, but a couple interesting things. In 2014, we were actually acquired by VMware, and we were going to build the database as a service for vCloud Air, which was VMware's cloud offering solution. Uh, Unfortunately, VMware, or maybe fortunately, but VMware abandoned their vCloud Air. And so with that, Continuent broke away and became independent again from VMware. So it was kind of interesting being selected to work with VMware. So that's a pretty big company, a pretty big player in the space, and we were quite glad to work with them. But now we're back on our own, and we decided to release some hardened security features in 2017, which is critical, especially in the cloud space. And in 2018, again, even more changes and more improvements to our multi-site clustering uh, offerings. And we saw our first 10-year anniversary this year. And now in the feature is cloud. So stay tuned for Tungsten Cloud. Anyway, thanks so much for listening. Again, my name is Matthew Lang, and there's my email address. Any questions or you just want to chat about tech, or anything else, feel free to drop me a line. Would love to talk to you. Have a great rest of your day and make sure you see the rest of the High Noon series. Thank you.